All right, guys, here is the test review for your 1617 solving equations with square roots, rational equations, linear inequalities, and solving by factoring. So make sure you go over your 1.6 quiz that we went over last week in class, where you have the solving by factoring and the square roots and the rationals, because you'll have stuff like that on there as well. But when we solve equations that involve square roots, the first thing we want to do is isolate our radical. So in number one, I'm going to circle the radical. I'm going to subtract 7 from both sides. So I still have that -1 on the outside, and then 2x plus 3 on the inside of my radical equals 12 minus 7 is 5. So I'm going to divide both sides by -1 to get that -1 to go away. So we have left the square root of 2x plus 3 equals -5. And now to get the square root to go away, we square both sides, because when you square square root, it cancels out. So you have 2x plus 3 equals -5 squared is 25. And then going to subtract 3 from both sides. So we have 2x equals 22. Divide both sides by 2, and x equals 11. So remember, before we move on, let's go back and check just to make sure that the answer that we found works. So I'm going to take 11 and plug it back in here. I have 7 minus the square root of 2 times 11 plus 3. Does that equal 12? So 7 minus 22 plus 3 equals 12. 7 minus the square root of 25 equals 12. Well, the square root of 25 is 5, so 7 minus 5 equals 12. Does 2 equal 12? No, it does not. So x is not a valid solution here, so your answer for this question would be no solution. Remember, you've got to plug your answer back in to make sure that it satisfies your equation. Same thing with this next one. I want to isolate my radical. I'm going to get my radical all by itself. So I'm going to divide both sides by 3. So I have the square root of x plus 4 equals 9 divided by 3 is 3. Now that the radical is isolated, we want to square both sides. So when you square a square root, it cancels out. I have x plus 4 equals 3 squared is 9. Now I'm going to subtract both sides by 4, and I get x equals 5. So let's just go back and check it real quick. I have 3, and then 5 plus 4, does that equal 9? So 3 times the square root of 9 equals 9. The square root of 9 is 3, so 3 times 3 is 9. That is a valid solution, so x equals 5. Now we move on to number 3, and you notice that both radicals are already isolated. So you're just going to square both of them. When you square your square root, it cancels out. So now you just have a simple linear equation. 3x minus 5 equals 4x minus 11. We're going to move variables to one side and numbers to the other. So I'm going to subtract 4x because I like my variables on the left-hand side. I'm going to add 5. So we have 3 minus 4x gives me -x equals -11 plus 5 is -6. Divide both sides by -1, and we come out with x equals 6. Let's just plug it back in real quick and make sure that it satisfies our equation. So 3 times 6 minus 5 on this side, square root of 4 times 6 minus 11 on this side. So 3 times 6 is 18. And over here we have 4 times 6 is 24 minus 11. So 18 minus 5 is square root 13. Over here, 24 minus 11 is the square root of 13. That is the same, so we are good to go. Okay, in number 4, if you guys notice, this is a rational equation, but in this case, we have a fraction set equal to a fraction. When you have a fraction set equal to a fraction, you can simply cross multiply. So I'm going to say right here, -8 times x minus 2 equals 5 times x plus 4. So if we distribute my -8 here, I have -8x plus 16 equals, distribute our 5, we have 5x plus 20. And now we'll just simply solve the equation by moving letters to one side, numbers to the other. So I'm going to subtract 5x from both sides. And then I'm going to subtract 16. So we have -13x, my 16's cancel out, equals my 5x's cancel out, and 20 minus 16 is 4. divide both sides by negative 13, and we come out with x equals negative 4/13. Go ahead and throw that back into your denominator. Make sure it's not 0. You can plug it into the entire equation, and you'll see that it does satisfy, so that is a valid solution. Same thing here. We have a fraction equal to a fraction, so you simply cross multiply. 1 times negative 8 equals x plus 4 times x minus 2. So on the left-hand side over here, we have negative 8 equals. We're going to FOIL this. So we have x squared minus 2x plus 4x minus 8. So I'm going to combine like terms. I have negative 8 equals x squared plus 2x minus 8. So since we have a quadratic, we're going to move everything to one side, set equal to 0. So I have plus 8 on both sides. I'm left with 0 equals x squared plus 2x. My 8's cancel out. And now we'll factor. What can you take out of both x squared and 2x? Well, I'm going to take out an x, and I'm left with x plus 2 equals 0. So you have two solutions in this case. You have x equals 0, and then when I say x plus 2 equals 0, I get x equals negative 2. Plug them both back in. Make sure it does not create 0 in our denominator. It will work, both solutions, when you plug them back in. So they both are valid solutions. And then the next one, again, it's a fraction equals a fraction, so you cross multiply. So we have x plus 1 times x minus 5 equals x plus 3 times x minus 4. So in this case, we're just going to FOIL on both sides. We have x squared minus 5x plus x minus 5 equals x squared minus 4x plus 3x minus 12. It's a quadratic, so let's move everything to one side. We can combine like terms, I guess, first. So x squared minus 4x minus 5 equals x squared minus x minus 12. So move everything to one side. I'm going to subtract x squared, add x, and add 12. So we're going to subtract x squared, add x, and add 12. So my x squareds will cancel out. Everything over here cancels out. So I have negative 4x, excuse me, and a positive x gives me negative 3x. Negative 5 and positive 12 gives me plus 7 equals 0. So now that our quadratic is gone, we've eliminated the x squared. So I'm just going to move 7 over. I'm going to subtract 7 from both sides. So I have negative 3x equals negative 7. Divide by negative 3, and x equals positive 7/3. And again, throw that in. Make sure your denominator is not 0. It is a valid solution, so we're good to go. Now, coming down here, guys, to our rationals. This is where you have to get a common denominator and make sure that your denominator does not become 0 once you do get your common denominator. So the first thing we're going to do is factor. Over here, I can factor x squared minus 9 into x plus 3x minus 3. So a common denominator between all three of these fractions is going to be x minus 3x plus 3. So in my first fraction, 6 over x minus 3, it has the x minus 3. It's missing the x plus 3. So what you do to the bottom, you do to the top. My second fraction has the x plus 3. It's missing x minus 3. So what you do to the bottom, you do to the top. And our third fraction has both denominators. So now that we have created equivalency, everything has the same denominator, you can cross the bottom off. So you just have the equation 6 times x plus 3 plus x minus 2 times x minus 3 equals 36. So we're going to distribute and then FOIL. So I have 6x plus 18 plus x times x is x squared minus 3x minus 2x plus 6 equals 36. Combine like terms. The highest exponent I have is x squared. I have 1 x squared, so that's good. Now I have a positive 6, negative 3, negative 2. That's going to give me plus x. Then I have 18 plus 6 gives me 24, so plus 24 equals 36. Now I have a quadratic, so I'm going to set everything equal to 0. So let's minus 36 from both sides. And we're left with x squared plus x minus 12 equals 0. So now we know we can factor this. What are the factors of negative 12? That multiply to give me negative 12, but add to give me 1. That's going to be x plus 4 and x minus 3. So I have two x values here. When I set each parenthesis equal to 0, I have x equals negative 4, and I have x equals positive 3. So let's go back up to our original and check our denominators. If I plug in negative 4 into any denominator, it will not become 0. So negative 4 is a valid answer. If I plug 3 into my denominators, if I plug 3 in that first denominator, 3 minus 3 is 0, which immediately makes our fraction undefined. So x equals 3 is not a valid solution, so you have to cross it out. Okay, same thing. We have another set of rationals, so I'm going to factor this denominator, and this factors into x plus 4 and x plus 3. So to get a common denominator, I look at my first fraction. I have the x plus 4. It's missing the x plus 3. And what you do to the bottom, you do to the top. So we're going to multiply by x plus 3. My second denominator has x plus 3. It's missing x plus 4. So I'm going to multiply the top by x plus 4. And then our third fraction has both denominators. We're good to go. So now that we've created, again, our equivalency, our denominators are gone. So we have the equation 5x times x plus 3 minus 3x times x plus 4 equals 2. So we'll distribute. 5x times x is 5x squared. 5x times 3 is plus 15x. Negative 3x and x is minus 3x squared. Negative 3x and 4 is negative 12x equals 2. So now we'll combine like terms and we'll move the 2 over. So our entire quadratic is set equal to 0. So I have 5x squared minus 3x squared is going to give me 2x squared. A 15x and a negative 12x gives me plus 3x. And I'm going to move this 2 to the other side so it becomes minus 2 equals 0. And now we're going to factor. So a times c, 4 times negative 2. What are the factors of negative 4 that multiply to give me negative 4 but add to give me a positive 3? And that would be 4 and negative 1. And remember, guys, since our a term is not 1, we have to divide both of our factors by our a term, which is 2. So these two parentheses become x plus 2 and 2x minus 1 equals 0. So when you solve these two, you get x equals negative 2, and you get x equals positive 1/2. And when you plug either one of those numbers into your denominator, it does not become 0, and you can check all of the work, and everything will work out perfectly. All right, the second half of your test is going to consist of our linear inequalities. We're going to have to solve them, we're going to have to graph them, and then write our answer in interval notation. All three things. It's really, really important, guys, that you remember that if you multiply or divide by a negative number, you have to flip the inequality sign. Remember that if you have a less than or greater than symbol, it has an open dot, and that's going to be a parenthesis on our answers for interval notation. If you have an or equal to underneath either the greater than or less than, it's going to have a closed dot, and that will use a bracket. And anytime we have infinity, we always use open dots. So the first thing I'm going to do is say, okay, I have this inequality. I have x's on both sides. Let's solve for x. Let's first distribute our 7. So we have 38 plus 5x is greater than 7x plus 28. Now I'm going to move x's to one side and numbers to the other. Like I said, I like my x's on the left-hand side, so I'm going to subtract 7x, and then I'm going to subtract 38 over here from both sides. So my 38's cancel out. I have negative 2x is greater than 7x's cancel out. 28 minus 38 is negative 10. Divide both sides by negative 2. As I divide by this negative 2, I have to flip my inequality. Then negative 10 divided by negative 2 is positive 5. So right here is our solution to our inequality. Now our next step that we have to do is we have to graph it. So I need to see 0 on your number line, and I need to see your boundary point, which is 5. It's less than, so I'm going to have an open dot, and less than, I'm going to shade to the left. It's everything that is less than right here, 5. So my interval notation, remember we read from left to right, so my interval notation, negative infinity over here on the left. So we have negative infinity, and it goes up to 5, and it does not include 5, so that's going to be a parenthesis. So all three of these things are your answer for this question. All right, number 10, we're going to do the same thing. I have an inequality. The first thing I need to do is solve for x. So I'm going to distribute this negative 7 here. So I have 5x minus 7x minus 7 is less than negative 9. Combine like terms here. I have negative 2x minus 7 is less than negative 9. Let's add 7 to both sides. Add 7 to both sides. We have negative 2x is less than negative 2. Divide both sides by negative 2. As I divide by a negative number, I have to flip my inequality sign. So negative 2 divided by negative 2 is going to give me a positive 1. So my inequality solution is x is greater than 1. So now when I go to graph it, I have 0 on my number line and I have 1. I have an open dot at 1 because it does not include that value. And I want all the values that are greater than. So it's going to be everything here to the right. So remember, as we write our interval notation, we read from left to right. So our interval notation is from 1 to infinity. Everything along there from 1 to infinity, but it does not include 1. That's why we have parentheses on our 1. All right, we go over here to this one. Again, same thing. We want to solve our inequality. So I'm going to first distribute my 8. So 8 times 1 is 8. 8 times negative 4 is negative 32x greater than or equal to 60. I'm going to subtract 8. Subtract 8 from both sides. We get negative 32x greater than or equal to 60 minus 8 is going to be negative, or positive, 52. Divide both sides by negative 32. When we divide, ladies and gents, by a negative number, we have to flip our inequality sign. So we flip our inequality sign, and we have 52 divided by negative 32. Well, we can simplify that. 52 divided by 4 is 13. And 32 divided by 4 is going to be negative 8. So x is less than or equal to negative 13 over 8. So we're now going to have negative 13 over 8 on our number line and 0. We want all the numbers that are less than or equal to. So I have a closed dot at negative 13 over 8, and I want all the numbers that are less than or equal to. So as we write our interval notation, we're going to read left to right. So we go negative infinity to negative 13 over 8, and that's going to be a bracket because it includes the value negative 13 over 8. Okay, number 12, same thing. First thing I'm going to do is distribute this 7. So I have 7 minus 35x. Now I have a negative here. I'm going to distribute this negative. So I have minus x minus 3 is greater than or equal to 4. So combine like terms. We have negative 35 and a negative x gives me negative 36x. 7 minus 3 is going to give me a positive 4. And we're going to say greater than or equal to positive 4. So now I'm going to subtract 4 from both sides. I have negative 36x is greater than or equal to 4 minus 4 is 0. We're going to divide both sides by negative 36. So we're dividing by a negative number. That means we have to flip our inequality sign, and we have x is less than or equal to 0, which is a totally fine answer. So we have our number line. Our boundary line is at 0. I'm going to have a closed dot at 0, and I want all the values that are less than or equal to. And then for our interval notation, it's going to be negative infinity to 0 with a bracket because 0 is included. So here is our answer for that question. Okay, same thing on this one. We're going to distribute our 4. So 4 times 8 is 32. 4 times 2x is plus 8x minus 2. X is less than 3. So combine our like terms here. We have 32 plus 6x is less than 3. We're going to subtract 32 from both sides, minus 32. And we get 6x is less than negative 29. So we'll divide both sides by 6. And we get x is less than negative 29 over 6. So on our graph, do my number line up here, we have negative 29 over 6. We have 0.
Can I do my hairspray?
Sure, honey. And then we have everything open dot, and its x is less than, so it's everything to the left-hand side here. So it's negative infinity to negative 29 over 6, and it's a parenthesis. It's not included in our value, so there is our answer. Okay, our last two here, guys, are ones where our x value is in the middle. So when it's in the middle, remember, we have to treat both sides of the inequality exactly the same. So if we're going to try and isolate our x here, I'm going to add 6. Well, in order to make an equivalent inequality, we have to add 6 to the right-hand side and to the left-hand side. So we have negative 4 less than or equal to 2x, which is less than 12 and 6 is 18. Now I'm going to divide everything by 2. So I have negative 2 less than or equal to x, which is less than 9. So as we go to graph this, I have two boundary points, one at negative 2 and one at 9. 0 would be in the middle. I have a closed dot at negative 2 because it includes this value, an open dot at 9, and then we're going to shade in the middle. As far as our interval notation goes, this is negative infinity to positive infinity. We read from left to right, so our value starts at negative 2, and it's included, so it's in a bracket. And they end at 9, and it's not included, so it's a parenthesis. So here is our answer for this question. And then our last one, again, is the same thing. We have where our x value is in the middle. So in order to get x by itself, the first thing I have to do is I'm going to have to multiply the numerator by 2. So I have to multiply the right side by 2 and the left side by 2. So now I have 2 is less than 3x minus 1, less than or equal to 10. So now we're going to add 1. We have to add 1 to everything. So we have 3 less than 3x, less than or equal to 11. And now we're going to divide everything by 3, and we get 1 is less than x, which is less than or equal to 11 over 3. And for our graphing, we have 0, we have 1, and we have 11 thirds. We have an open dot at 1. It's not included. We have a closed dot at 11 thirds, and we're going to color in the middle. So our interval notation would be 1 to 11 over 3 with a parenthesis on 1 and a bracket on 11 over 3.